Hello everyone, greetings and welcome to the first video for section 3.6. So we're moving along in our building our knowledge base of different differentiation rules. So we've already learned the product rule and the quotient rule and the power rule and a few other things about differentiation. So we're just going to kind of expand what's in our toolbox here. So section 3.6 is about something called the chain rule. And let me show you what this is for. So let's look at a function like this. So h of x equals x to the 6 plus 4x, that whole thing raised to the 20th power. Now, when you look at this and you think about taking the derivative, well, the first thing that comes to mind might be to use the power rule. All right, so we see we have something raised to a power here. So move that down to the front, subtract 1. And then you'd have x to the 6 plus 4x raised to the 19th power. But we have this other function on the inside here. So it's not totally clear what we have to do to deal with that. Okay? And also notice with this, that this setup is kind of a function within a function, right? So notice on the outside, we have this something raised to the 20th power. So that's kind of like our outside function. And on the inside, we have the x to the 6 plus 4x. So again, you see there's a function within a function here. So how do we deal with that? Well, this is where this thing called the chain rule comes in. So let's suppose we have g and f and g that are functions, and that for all x in the domain of g, for which g is differentiable, f is also differentiable. And so if we're looking for the derivative of what we call the composite function, okay, so because we're looking at compositions of two functions, so if h of x is given by f of g of x, or maybe you've seen this notation here in the middle with that kind of wide open dot there, that's another way to show composition of two functions. Well, the derivative is found by taking the derivative of f and evaluating a g and multiplying by g prime. Oh boy, that looks like a lot. Okay, so let me break that down a little bit more, break down the process here. So here's how you do it. If you want to differentiate the composition of two functions, so f of g of x like we have here, we first identify which one's going to be f and which one's going to be g. Once we have that, then we'll take the derivative of f, then evaluate it at the function g, which will give us f prime of g of x. Then we'll find g of prime of x, so the derivative of g, and then we multiply the two things. Okay, and again, I know that may look like a lot right now, so we'll do an example to kind of explain this. Okay, so back to the one we were just talking about. So h of x is x to the 6 plus 4x to the 20th power. So the first thing we want to do, based on what we saw on that last slide, is identify our f of x, and I'm going to write this one over here, our g of x. Okay, and remember, g of x is the inside function, and f of x is the outside function. So it might be helpful to, or I will say often it's helpful to first identify the inside function. So which one's on the inside of another function? Well, as we were just talking about, that would be x to the 6 plus 4x. So our g of x is x to the 6 plus 4x. And then what's going to be the outside function? We have to be a little careful about this, because it's not just to the 20th power, right? It's got to be something to the 20th power, and we have to think about if you have a function inside of a function, that means that the inside function took the place of a variable. So again, on the outside, we have something raised to the 20th power, so it looks like our outside function might be x to the 20th. And let's double check that. If we take the inside function g, x to the 6 plus 4x, if we plug that in for x in our function f, do we get this function here? And hopefully you agree with me that the answer there is yes. Okay, so we've got our f and our g's identified. So now what we do, based on what we saw on the previous slide, is we'll find f prime of x. So let's take our derivative of our outside function here, which is going to involve the power rule. So we'll bring the 20 down, subtract 1, so this becomes 20x to the 19th. But we're not done here. Now what we have to do is take f prime and evaluate it at g of x, which means we need to plug g of x into it, which means our function for g over here is going to get plugged in for x here. So we have 20 times now x to the 6th plus 4x raised to the 19th power. Okay. So that's that second step. Next thing we do now is find g prime of x, which we can do that using our power rule. So that'll give us 6x to the 5th plus 4. And now that we have f prime of g of x and g prime of x, then we just multiply the two to get our derivative. So I'm going to have to write it above everything because I ran out of room. So it's going to be up here. So our h prime of x will be 20 times x to the 6th plus 4x raised to the 19th power times the g prime of x, which is 6x to the 5th plus 4. And we can just leave it like that because, as you notice, if we wanted to go any further, we'd have to do x to the 6th plus 4x to the 19th power. And I don't know about you guys, but I definitely am not excited about doing that. Okay? All right, now one thing I want to point out before we go on to our next example is people often confuse the chain rule and the product rule. Okay, so just to kind of reiterate, the chain rule is when you have something that's set up like what we have here. So here we can have our h of x, we can write it as f of g of x, a composition of two functions. The product rule, as its name says, means we have to have two functions being multiplied. So we need to have something like h of x equals f of x times g of x. Okay? So when you're trying to figure out which of these rules do I need to use, ask yourself, do I have two functions being multiplied or do I have a function within a function? Okay? All right, let's look at another example of the chain rule. So here we have this function L of t, which is given by e to the 10 minus 2t. And we first have to identify, does this look like a function within a function? Well, I notice that in the exponent here, we see this 10 minus 2t. And I suppose that could be within a function like e to the x or e to the t, right? So let's identify our functions f and g here. So our f of x will be, or actually we'll hold on that, our g of x will be the inside function, so the 10 minus 2t. Our f of x then would be our outside function, and so in this case it's going to be e to the t, and I realize I'm using f of x and g of x, but our variable here is t, not x. And now we go through our process here. So we find our f prime. So we know the derivative of e to the t just gives us e to the t. And then we evaluate that at the function g. So we plug in the function g, or in this case it should be g of t, not g of x. So I have e to the 10 minus 2t. Then we find g prime. Let's take the derivative over here, again using our fact that the derivative constant is 0. Derivative of negative 2t using our power rule would just be negative 2. And then we take and multiply those two things. So we do f prime of g of x times g prime of x to get our derivative. So our L prime of t here is going to be e to the 10 minus 2t times negative 2, which if you want to write that in a little bit more simplified version, or just a more common way to write that, would be L prime of t is negative 2 times e to the 10 minus 2t. Okay? And that is our derivative. Fun stuff, right? Oh, I know. All right, this problem here will be one that you'll do for classwork. Now this is a fun problem because as you can see, you have a function within a function. You have that cosine of root y within something raised to the 10th, but then notice that one's also a function within a function because you have root y inside of a cosine. So this is chain rules within chain rules. It's just probably the most fun you'll have this week. All right, thank you guys for your attention.